So the thing here is it's like they're all right. It's just which one is
Yeah.
right by the that they give. So right. Just presume we're gonna go in order here for these. Is that right?
Mhm.
Okay. All right. So I did get the other ones loaded up here. Looks like, come on, load up page. All right, up to number 7.
Yeah. I kind of started that one in class, but I kind
Yeah,
of
don't overthink any of these. They remember, finals are meant to test your knowledge generally of the class. So like if things look congruent or you feel like there's a proper thing here, yeah, then do it. So you had it right. You have 5/4 equals 4x minus 8 over 16. Okay.
Mhm.
Notice that x is 7 in all of these.
Oh yeah, so we
And that's kind
can.
of important. That just tells you, okay, x is 7. Why don't I just find AB?
Mhm.
And it looks like AB is 20.
Yep.
All right. Now, the other thing I always tell students here is that like when you see a couple of problems that are similar, that's a pretty good indicator that you're going to get one of this type. So you're going to get some sort of proportionality thing here.
Okay. So this whole side is 14, so 14 minus 8 is 6. So EA no 6. So then we can do
What's the
4 to
whole length from?
8 is to 2x to 6.
No, it has to be part the whole. It's the triangles you're looking at, not the like this B to C is nothing. This B to C is nothing. You have to get the whole triangle. And you're doing
Oh,
it right.
okay.
You're like, okay, 6 and 2x, and then 14. And what I was about to ask you is, what's the other one here?
The long one would be 2x plus 4. Or wait, just
Yes.
4.
No, 2x plus 4. It's the whole thing. It's the whole
Oh,
thing. You have
okay.
to add, you have to,
Oh yeah, yeah. Got it. 6 14.
all right. So this one requires a little more effort to solve, but I'm sure you can do it. And it's nice that the answers are there because they tell you, okay, it's either 3/2 or 14/3. Um,
So I got for x, I got 3/2. So we can cross out C and D.
good.
And
And so you've got
then
to find AB. So you got to put that back in for M.
3.
It is 3. Good.
So B.
All right. Good job on that. Kind of looks like you've done 9, although maybe not
Oh yeah.
finished it. You want
I
us
just kind of
to
started it, I think.
you're doing a good job here. Although I should say that because it's multiple choice, you can kind of finagle your way through this problem without actually doing it.
Mhm.
So we're finding the length of A to E right here.
Mhm.
And like they want you to do it exactly, but you can actually use the ordered pairs like you have here. And then, truthfully, you can kind of just estimate it. Like C
Count
is
it.
about 4 and D is about what is D, about 8. So like you can kind of count and just be like, yep, looks like it's D. You don't have to like do the distance formula, even though you should. Like that's the right way to do it. But your final is multiple choice, so you can do it the way that you need to get the right answer.
Wait, so how did you estimate it?
Counting, just saying, well, it's -5
Oh,
to 3. It's about 8. I mean, they're far enough apart. Like if I were making the answers, I would make the answers really close together so that you couldn't do that. I would do,
yeah.
7, 8, square root of 65, square root of 73 or something. Because I wouldn't want you to just be able to figure that out real quick, but
Yeah.
stopping you. Now, do you want us to do the distance formula? Do you want us to review that?
Yeah, I would like to do that because my teacher's kind of a stickler about that kind of stuff. So
Okay. All right. So we do need the ordered pairs at A and B. So A is 3, 6, and E is -5, -5, 5. And you've written the formula correctly. It's good to sometimes label like, okay, this is X1 and this is Y1, X2 and Y2. And then you're substituting them into the formula there. -5 minus 3 squared plus 5 minus 6 squared square root.
oh, okay. So I got the square root of the 65.
But
So oh, I see what you're saying now. Because the square root of 65 is like right around 8. Gotcha.
and they're far enough apart that you can't really like
Yeah.
mess it up. Me can, but like, and so these are things I teach. I do SAT prep, ACT prep, and these are kind of strategies that I talk about with students because there's really no reason you can't like beat these tests. You just
Mhm.
have to you need a little help, uh, coach kind of thing. All right, I see 12 next. I'm missing 10 and 11. I don't know if that was on intentional. Is it okay if I go to 12?
Oh, did I not send you?
I don't know. They didn't come. Sometimes they don't come in order. I'm looking here. Let's see. Double check.
Yeah, no, I just totally missed it. Let me resend it. And then 10 I kind of already started.
Okay.
But 11's all clear.
So can we do 12 in the meantime? And then when I get that kind of
Yeah, let's
going,
do 12 in
we'll
the
come back.
meantime then.
Okay, here we go. All right, in the figure SQ equals 6, RQ equals 13, and ST equals 3, find RT. This is one of those really awkward similar triangles where it's like you can't really see it in two dimensions. Like you like imagine folding the triangle along QT and like laying S kind of over here.
Mm-hmm.
That's your triangle here. So it's really QTS like that. It's similar to QTR like that.
Oh,
6
okay.
and 3, 13 and X.
Because
Like if you
I don't know if you know if you've like seen this, but we were kind of like I think this is one of those problems that we were told to like do like a T shape or whatever, like follow the lines or something.
yeah, it easier if you could cut this triangle out, QST, and then flip it over, fold your paper right along QT, and then
Yeah,
flip this that
but
way.
yeah, this makes more sense.
I'm big on drawing two separate pictures, getting away from, there's a lot going on here. And then you can see the proportion real well. You can say, okay, I can
Mhm.
basically map 6 and 13 or 6 and 3 and then 13 and X. And so go ahead and solve that for us, please.
And so does this mean that they're similar or
They have to be. Yeah. So they're similar by angle, side, angle.
angle, side angle?
Yeah. Angle, side, angle.
Oh,
As you can see that Q and the T match up in both of them.
how does the T match up? How is that the same angle?
Because well, it's that's a good question. Why is it the same? I don't have the answer for you.
Because wouldn't that be because it's like the line from QT is kind of like an angle, so
Yeah,
would it
you could argue that you can't really look at that and make any decisions on it. Um,
like it kind of looks like QTS is like I don't know like
yeah, that
80
one's a
degrees
Q.
and then
Yeah, right,
QTR is like
right. I'm not sure. I can fully answer your question. I know that from the past, there's errors in these reviews that never get cleaned up. Um, so this might be one to throw at your instructor and say, "Hey, I was working on this problem and I ran into a little
yeah.
snag," and see what he has to say.
Hmm.
What I was going to suggest, so we got X over 3 equals 13 over 6 and 39. Oh, well, so you are correct. You are correct here. So this is not right what I've done. This is completely because the answer isn't, well, I guess it is 13 over 2. So I think it's B. If we had the answer sheet, I guess we could confirm that, but
Hmm.
maybe save this for another time here.
Yeah, for sure.
All right. So I think I've got that that pen loaded up here now. Yeah, there it is. Oh, come on, load up. All right, that didn't load up real. So let's go on to number 13. This looks. Oh, you already got 13, so we can go back. Okay, 14. So like I mentioned, you're going to get one like 14 or 15
Hmm.
in here. You said you get a sheet, right? You get a review or a note card or something you can take in.
Yeah.
So there's a
It's like a piece of printed paper.
all right. So here is, let me grab a snip of something that's fairly straightforward. I'm trying to find the one that's got all three of them. This starts with the Pythagorean theorem, but here are the 3 formulas that you're looking for here. So you have to first order the sides, and they're already ordered for you, which is nice, from smallest to largest. But here are the 3 possibilities. So for a right triangle, it's the one on the left. That's the one you're used to, the Pythagorean theorem. The middle one here is the obtuse, and the one on the right is acute.
Okay.
The other possibility, I suppose, the way it's written is that this is not a triangle, which I guess we could talk about, but I mean, that's a pretty big exception. So you do have to figure out, okay, what is 10 squared plus 11 squared, and how does that compare to this 20 squared? 100 plus 121. How does that compare to 400? And it's obviously a lot less. So you would say acute. Is that okay? Clear?
Yeah, sorry, I was just writing down the little picture you pulled up. So we would square. The biggest side is always going to be C, right?
That's right.
The
Yeah,
biggest
it's
number.
A, B, and C.
Yeah. So it's going to be acute.
It is acute, yes. You could also try to draw it, and you'll see that as well, but it's a little harder to do that way. You have to really be pretty good with your drawing to make that happen.
Mm-hmm.
All right, so 15 here. What could you say about 15? Let me snip that one in. It's already in order, which is nice. You don't have to think about that. So you've got a square 21.5 squared, 24 squared, and then 55.5 squared.
It's also acute.
So that would be the correct answer, but there's a huge but here. This is not actually a triangle. And I want, you're like, wait, I just did all that work. Yeah, it is. There's this thing called the triangle inequality theorem, which actually applies to this problem here. You want the two sides have to be bigger than the third
Oh
side.
yeah.
And so this one, these two sides are not bigger than this. So it is not a triangle. Okay. But that's a pretty big exception. So you might want to ask your instructor,
Mm-hmm.
hey, should we be on the lookout for stuff like that? This would also be a good thing to put in your note sheet down here. The fact
Yeah.
that two of the sides to be bigger than the other. There's a few other ways to write it, but this is the most compact.
Yeah. Got it. I remember that. So I'll keep that in mind.
Okay.
No,
Strangely enough,
no.
that pic.
change of plans. Can we just kind of go through it and just kind of like skim over the problems to see what kind of equations or like formulas I'm gonna need?
Sure.
If that's okay, because I kind of
Yeah.
just want to focus on the like this cheat sheet's like my top priority because it's due sooner than the actual packet.
Wow, that's rough.
Yeah, it's due tomorrow morning.
Okay.
I know.
All right. All right. So for problems like this, I'm gonna look for the
I think this is like the altitude and
well, the trying to find something that gives you everything here. There's three triangles. There's the way I show it is like this, is there's a short leg, a long leg, and a hypotenuse, and there's the
oh yeah.
small triangle, the medium triangle, and the large.
Isn't that
And
only for 30, 60, 90s though?
now this is this is there's three triangles in one here, small
Oh,
one, medium one, and then the large one. And based on what you have, you can create proportions for that. And they kind of show all these, there's maybe a way to get them all in there. That's what I'm looking for here, but I don't see it, but we should, maybe that's enough here, but it's like, if you have four squares, you can create a ratio if you're missing something.
hmm.
I don't know if you remember that or not.
Not really.
Okay, let me see if I can find it. This is I don't know what this is called, triangle ratio. I can't find it. So let me just go on to another problem here and see if I can,
Sounds good.
but you will get something like that. Pythagorean theorem ought to go on there. You know, a squared plus b squared equals c squared. And you
Hmm.
kind of mentioned it before. You do need the 30, 60, 90 triangles and the 45, 45, 90. So here's the 45, 45, 90. So it's x, x, and x root 2.
Yeah, that's good. Let me write that down. All right, got it.
Okay, the other one I'm seeing here is let's see, sine, cosine, and tangent. So sine
Oh yeah.
of an angle is the opposite over the hypotenuse. Cosine of the angle is adjacent over the hypotenuse. And then now you also may need to know the cosecant theta, which is the reciprocal. It's 1 over sine theta. It's also the hypotenuse over the opposite.
Oh, and this is like the negative one, right?
No, these are different. These are
Oh,
that's for finding angles, which I guess we'll do shortly.
so what's this?
These are just, it might ask you for the sine, cosine, tangent, cosecant,
Mhm.
secant theta of an angle and a triangle. And that's all the ratios of sides.
So what's the secant for?
let's just say, I don't know, they might ask you for a problem. I'm just going off of problem 20 where it gives you sine, cosine, and tangent. It might not ask for this. That's more of a algebra 2 trig or pre-calculus trig thing,
Mhm.
but I couldn't say for sure. So
Cool.
looks like they're, and I keep that. So this is where I've run out of problems. Are 21, 22. Okay, so 22, 23, 24. So we need law of sines, law of cosines. So here's a triangle, non-right triangle, and let's see here. We got A, B, C, little a, little b, little c. So law of sines is like this. It's either sine A over A equals sine B over B, sine C over C. But you can also flip this. So like, I don't know if you want to make two formulas, but you can also do it this way. And then you're also only using two of them. Like you would use A's with B's or A's with C's or B's with C's. You would never
Use all three.
all three. Yeah,
And then but those two mean the same thing, right?
they do. You're just flipping
Okay.
them. There's also law of cosines. So law of cosines is so use law of cosines when you have all three sides or a side angle side situation. And I didn't say this about when you use law of sines. It's when you have an angle side pair.
Angle side pair.
Like imagine you have big A and little a, or you have big B and
Oh,
little b.
okay.
That's what I mean by a pair.
Got it.
Whereas law of sines, you use it as when you have a side angle side or all three sides. This comes in three flavors, but they're all really the same. But I'll write them all here for you if you would like.
And those all mean the same thing.
Well, they're all for solving something different, but they're all the same. They're always solved for the side that you're looking for.
Oh yeah.
So you use these three when you're given a side angle side.
What is the big C at the end of
That's the angle. Oops, I messed that up. Good catch on that.
Oh, okay.
Yeah, that's important. It's not the same each time.
Got it. And then do you need more pages?
Yes, but let me just follow up this by saying there's also sometimes students have this already solved for C, big angle C, and that's when you have side, side, side. So they'll have it like this where it's A squared plus B squared minus C squared over 2AB cosine inverse. So like this is derived from the first one. Like you get it by solving the first one for big C,
Yeah.
but you can do the same thing for B. It's A squared plus C squared minus B squared over 2AC cosine inverse of all that. I don't know if you want the last one for A.
No, it's fine.
Okay. All right. Yeah. So some more pages would be helpful.
Sure thing.
I did finally get 10 loaded up here, but so similarity, there's only a couple of ways that you can do similarity. It's angle, side angle. No, sorry, I'm thinking of something else. So I think you have triangle congruence, but maybe you guys don't do that. And that was in the first part of the year. Yeah, it doesn't look like you've got that. Yeah. So send over some more pages. Probably need some volume formulas.
Oh yeah.
Let's start here with circles. So for circles, you have the circumference of 2 pi r, or pi times diameter. The area is pi r squared. They sometimes want you to find the area of a sector, the pizza slice. The angle at a 360, pi r squared. If they want you to find the sector length, so the called the sector length, I'll say measure. If the angle at a 360, 2 pi r times 2 pi r. So this would be the area. Is this one, and then this other one, it's the length on the outside. That's the difference between them.
Oh, okay. So area of the sector and then length of the sector. Times 2 pi r. Okay.
All right, so next thing I'm seeing here is a reminder that vertical angles are congruent. So anything that kind of meets at an X, these angles are congruent, and then these other angles are congruent.
Mm-hmm.
The next type of problems I'm seeing are where there's 3 cases. There's tangents are congruent, the tangent, and the tangents are congruent. The next case is secant. This is secant. They cut through in 2 places there. So I've got to label these A and B, C and D, and it's A times A plus B equals C times C plus D.
For the sector.
Secant. No, these are the lengths of these, yeah.
And then the top one is just tangent times the
Yeah,
tangent.
it's just that A equals B. But you might see a problem where that comes up, but kind of not clear. The other one that you might need is last one here is secant tangent. So A, B, C, this is a secant tangent, and it's A squared equals B times B plus B.
Sorry, one sec.
Yep.
Okay.
Okay, the next set of formulas here have to do with angles inside a circle. So we know that the central angle is the same as the arc length is the same. And
Mhm.
then the other possibility is when the angle is this is on there, so it's X and 2X. Those are kind of intuitive, but we'll keep going with those. So this is an inscribed, I guess I should say, inscribed central.
Yeah.
The other possibility is I give you a circle where there's the center, and I give you, this is M, this is big M, and this is X. X equals little m plus big M divided by 2.
Oh yeah.
And then we have to go exterior to the circle after this.
That dot is the center or
Yeah,
the center.
it's just meant to, it's meant to indicate they're off center.
Got it.
All right, so then there's 3 possibilities here. There's a tangent, tangent. Yep, that's not tangent. Tangent, tangent, X, little m, big M. And then there's secant, secant, X, little m, big M. And then the last one is a tangent secant. So X, little m, big M. All 3 of them, X equals big M minus little m divided by 2.
Nice.
All right, so last thing I'm gonna be able to do for you here is give you, I did drop something in the chat for areas and volumes. I would get all that down if you can. Last thing is
Yeah.
the equation of a circle. And we ought to do an example. So let's say, so it's X minus H squared plus Y minus K squared equals R squared. So the center is at H comma K, and the radius is R. But what I would add in as an example, I would say, okay, if it were like X plus 3 squared plus Y minus 4 squared equaled 9, this means that the center is -3 comma 4 and the radius is 3. And that will just sort of help you to remember, signage, what the signs are, the calculations.
So what are X and Y representing?
They're X and Y like you're used to. There's 2 variables in the equation.
Would
It's
this be for like 40 or?
Yeah, I saw one. Yes, exactly. 39
Oh,
and 40. 39 and 40.
gotcha.
All right, so that link in the chat, really super important. Make sure you click on that. It's got all the areas and volumes and surface areas that you might ever need. That would be good to have, but we do
Oh
have to
yeah,
stop
yeah.
here, unfortunately.
Yep. All good.
Yes,